In double bond equivalent, that is the next thing. A double bond equivalent is DBE. You can also call it DBE. DBE. Okay, and observation of the molecular formula of an organic compound can be used to predict accurately the possible number of pi bonds or ring bonds that are present. Pi bond or ring bonds that are present. Ring bonds or sigma bonds in the structure of a compound or that are present. So we have pi, we have different kind of bonds, and then we have ring bonds. Sigma bonds are stronger than pi bonds. Sigma bond are stronger than pi bonds. Why? Why is because pi bond tends to lap. Pi bonds tend to touch each other on the edge. Okay, while sigma bond tends to lap. See something like this. So if I want to draw this here, it won't touch the edge. It won't touch the edge. It will lap. So it will be like this. It will be something like see. This is more stronger. It is more stronger than this. So this is sigma bond, this is pi bond. So now observation of molecular formula can now be used to predict accurately the possible number of pi bonds that are present. So we are considering pi bonds here. Okay, so the presence of a bond or a ring reduces the number of hydrogen atoms. The presence of a bond or a ring, it reduces the number of hydrogen atoms by 2 in a compound when compared to corresponding acyclic or open chain. So example like this, for example, let me say, well, let's consider this example, propane. Propane for acyclic diagram molecular structure is what? C3, okay? The number of hydrogen present here is 8. You see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is 8 hydrogen present. So now the presence of a bond or a ring reduces the number of hydrogen. A ring like this, you have this like benzoic or benzene. So the number of hydrogen, the number of bond or a ring reduces. The presence of a bond rather reduces the number of hydrogen atoms by 2 in a compound when you compare it to acyclic. So we're gonna be practicalizing this or showing this out. So now if you want to draw this in acyclic, now if I want to draw the same ring here, I can have something like this. Okay, you can say, or this is, you see, this is also propane. Now right, this is propane, but this has become what? 1, 2, 3. 3 carbon, but this will not give me the same number of hydrogen here. You see, because I'm going to have how many hydrogen here? I'll have 1, 2, 3, 4. That is 2 hydrogen here. 2 hydrogen here. That is 2 hydrogen here. And 2 hydrogen here. Don't forget to subscribe to my channel. Comments, drop a good comment. You want to join or have someone, do it to make sure you inform me. You have I'll drop my contacts there, okay, to reach. All right, and you subscribe, you like, okay. So now the number of hydrogen present here is 1, 2, 3, 4, 5, 6. You see, hydrogen present here, Hy, is what? 6, and hydrogen present here is how many? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. This is propane. This is what? Cyclopropane. Now this cyclopropane here, you see, that's what. So the presence of a bond or ring reduces the number of hydrogen atoms by 2 in the compound when you compare to cyclic, that is acyclic. So this is double bond equivalent. Now double bond equivalent DBE is now expressed as what? Hx minus Hy divided by 2. That is the number of hydrogen that are present in the acyclic, that is the original compound, compare, that is the original compound, alkane, compare, that is acyclic, compared to the one you are given to compare. So now we have this as hx, that will be 8 minus 6 divided by 2. That is 8 minus 6 is 2. 2 divided by 2, that is what? So the double bond we have here, that is a pi bond, is equal to what? 1. So this show whereby X is the number of hydrogen atoms in the alkane and Y is that of what? Hydrogen in the what? That is in the bond you're estimating. So the number of pi bond present here is what? We have only one pi bond present in this particular compound. Okay, this particular compound, you have only one pi bond. Okay, so also putting into example here, you find that if I want to turn this, I want to have my normal number of hydrogen present here. Example is I gotta put this as cyclohexane. See what cyclohexane? Cyclohexane, that is what? Let's say or 2, right? That is, let's say 2. Or let me make this butane. Let's say butane. Now this is cyclopropane, the one we just cleaned off now. So we have two hydrogen present here. So here in this case now you can see that in butane here I have 6 here, right? So you can note that let me show you something here. Before butane rather, see, hydrogen is present. How many hydrogen is present here? You have how many carbon? 1, 2, 3. 3 carbon. And how many hydrogen do you have? You have what? 1, 2. That is 6 carbon. You can note that this is what? This is cyclopropane, right? Cyclopropane. And this is also propane. This is propane. So you can find out that example now, butane. If I want to change butane or I want to increase it, butane can also give me what? Butane, unless I add cyclo, butane will give me something of lesser viral hydrogen. So, but what about butane? Butane can also be what? Cyclobutane. So adding cyclo to an ane family or to a family or to a group, it increases it by bond. Simple. So what about butane? If I say butane and add if I want to add this guy here, butane can also be equivalent to what? Cyclobutane. You see. So in a nutshell, if you add cyclo to a compound, it tends to boost it up. Okay, it boosts it up. So if I add cyclo to ethane now, cycloethane will give me what? Ethane, just like cyclopropane. So let's confirm that ethane now. Ethane is what? C2, right? That is C2H4. So cycloethane, okay, ethane, that is cycloethane. Ethane is 2, right? So that is just too simple too. And ethane is just 3 bond, just a single 3 bond, and it's cyclo. So I'm gonna have hydrogen present here in just normal ethane. It can't just really, that is just 2, right? It's just 2. Okay, so it's just 2 here present like this. So if you find out that I'm gonna have hydrogen present is just 1. Okay, so now you can see, for example, if it's not clear, it's like this. You find out that, let's say we have let me talk about butane. So let's say butane, and let's say butane. So butane is what? C. For example, the previous one I just cleaned now, the one I just cleaned now, which is ethane. You have it as C2H4, that is double bond. So butane will also be how many hydrogen present? That is what C4H8. That is, you have 1, 2, 3, 4. So you're gonna have it as double bond present here. You have 1, 2, 1, 2, 4. You have 1, 2, 3, 4, 1, 2, 3, 4. Now let's consider cyclobutane. So butane, that is what 1. So you gotta put it in a rectangle form. Butane, it will be 3 bond. So here in these 3 bonds, how many hydrogen present there? 1, 2, 3, 4. This is complete. 1, 2, 3, 4. This is complete. 1, 2, 3, 4. 2 hydrogen here. 1, 2, 3, 4. 2 hydrogen here. One, 2, 3, 4. 2 hydrogen here. Oh, sorry, this is not correct there. So this is just 1, 2, 3, 4. Correct. 1, 2, 3, 4. 1, 2, 3, 4. So you see, you can find out here as well. And in butane, we have C4H8. So if you see butane now, butane is now how many here? Butane is C4H8 minus 2, right? That will be C4H6. Okay, so that means we have how many hydrogen present here? We have just 6 hydrogen. So if you check here, as well, this is cyclobutane. But what about if I reduce this to be 2? So I'm gonna have what? 1, 2, 3, 4, 1, 2, 3, 4, and I'm gonna have 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So you see, how many number of hydrogen are present here? 6, 6. This is what? Cyclobutane. So if I add cyclo to a compound, it gives me the next upper series. So if you add cyclo to a single propane, you have what? Propane. Okay. So if I add cyclo to butane, it will give me what? Butane. So what about if I add cyclo to pentane? If I add cyclo to pentane, what would it give me? Pentene. It will only lose a single hydrogen then to give me a change double bond. So if I add cyclo to pentane, it will give me what? Cyclo here, it will give me pentene. If I add cyclo to pentene, it will give me what? Pentane. So if I add cyclo to pentane, you can confirm that itself. It will just drop the hydrogen to change it, and it seems not to change it also. So like that. Okay. Now what about if you have pentane? You can depreciate it. So pentane can simply give me what? Cyclopentane. Okay, these are saturated and unsaturated compounds. So if I have also the way cyclo boost up, same way methyl. If I add methyl, it drops it. So if I want to change this back here, I just need to add methyl to this guy. So propane is 1, 2, 3. And that'll be how many bond? 2 bond, right? So I'm gonna have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. That is 1, 2, 3, 4. Now if I add methyl to this, it will drop back. Okay, this is propane, right? So if I add methyl to this, it will look the value. So that is just like you're saying plus CH3. 1 will go back, okay, and it will depreciate this as well. And if we're gonna add this together, I'm gonna have it as, you see, so it will just change it back to my cyclopropane. So for example, see, this is propane, right? This is 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4. So now let's see methyl propane. So let's see, consider methyl propane. Methyl propane also has its own, as this is just propane rather. So let's say we had methyl to heat. So I have something. So we're gonna add methyl. Let me say I add methyl to this propane. So I'm gonna have 1, 2, 3. Methyl is number 1 as branch, and I'm gonna have, so let's say we have methyl CH3, 1, 2, 3. So I'm gonna have 1, 2, 3, 4, 1, 2, 3, 4. I'm gonna have my 1, 2, 3, 4 as well. So this is being 1, 2, 3, 4. But propane is 2, right? So now you can see this example here. So as you can see, this is 1, 2, 3, and this is methyl propane. Okay, now if I add methyl to propane, how many hydrogen is present? 1, 2, 3, 4, 5 plus 3. That means the number of hydrogen present here is what? 8. Now this is equivalent, and this is also what? C3. How many carbon? 1, 2, 3. Though it is 4 carbon present there, okay, but this is methyl now. So this is propane. That will be C3H8. And you can also make sure, you can also find out that this is also what? Propane. So if you add methyl to a compound, it depreciates, it slows down, and if you add cyclo to it, it goes up. Okay. So also, if you want to find the double bond equivalent in this compound, you compare it to the original compound, and this is how many? Hydrogen is what? 8 here. So our original compound of this state here is 1, 2, 3, 4. Okay, this is 1, 2, 3, 4, and that is C4H12. That is butane. Okay, and that'll be 12 minus 8 over 2. That'll be 4 over 2, and that'll be 2. Okay, so in a nutshell, let's see these few examples. These few examples here. Number 1 we gotta consider is we consider ethane rather, ethane, or let's say ethane, ethine, cyclohexane, cyclohexane, like that. So in this state here, the original thing found out here is that in ethane, the H double bond equivalent is what is given as DBE equals to HX minus HY over 2. There is number of hydrogen present in the original one. So number of hydrogen present here, ethane is what? C2H6. That will be 6 minus, in ethane, the compound itself is ethane over 2. So it's always what? 0 over 2. So that means in ethane, the double bond equivalent is no pi bond, no sigma bond. Now in ethane is what? C2H4. So here we have the original compound is ethane, okay, of ethane is ethane, and ethane is C2H6. The original compound is what? C2H6. That will be 6 minus what? 4 over 2. That will be 2 over 2. That will be what? 1. So in family you have 1. In family. In A you have 0. Now in ine family, what do you have? The original compound, or this particular ethine is what? C2 and H2, and the compound, original compound is what? C2H6. Here you have C2H. So original compound is C2H6. So therefore, we want to consider that will what? That will be 6 minus 2 over 2. That will be 4 over 2, and that will be 2. So you find out that in ine family is what? Is double. Now in cyclohexane, this cyclohexane here, you find out is what? 6, right? 1, 2, 3, 4, 5. Okay. So it's 1, 2, 3, 4, 5, 6. Cyclohexane. How many hydrogen present there? Is just what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see, it's got 1, 2, 4, 6, 8, 10, 12. You must draw it to be able to get your answer. Okay, so this is 12. So that means that HY is 12, and originally the original concept itself is what it is. Hexane. Hexane itself is C4 C6 12 H14. So that will be 14 minus 12 divided by 2, and that will be 2 over 2, and that is what? By default, you should know that cyclohexane will give you what? Hexane. And in family is what? One bond. I come again. You don't need to just do this, okay? For just showing sake, you can solve this. But example, you should know that cyclohexane, from the example, that when you add cyclo to ethane, it will give what? Ethane. When you add cyclo, to give what? Ethyne. So for ane family, you only have 0 bond. Now for ane family, you always have 2 pi bond that are present in ethyne. And for ane family, you always find just a single pi bond and 0 pi bond there. So now cyclohexane is also hexene, right? Now ane family from the hexene is what? 1. So you should know this is 1. Now the other example I cleaned out is cyclohexane. Cyclohexane. Now cyclohexane will give you what? Hexine. And ane family is what? 2. So that means the double bond you should be expecting here in cyclohexane is what? We have just a single bond. That is just, it should be what? Cyclohexane, and that will be ane family. So let's consider that in cyclohexane is 1, 2, 3, 4, 5, 6. And you're gonna have just double bond somewhere. So you have 1, 2, 3, 1, 1, 2, 3, 4, 2, 2, 2, 2. So this is 2, 4, 6, 8. So this is 1, 1 present. So that will be 1, 2, that will be 2, 4, 6, 8, 10. So the bond present here is 10. And original hexane is what? C6H14. That will be 14 minus 10 over 2. And that will be what? 4 divided by 2. And that will what? 2. Okay? So here you can find out that in this case here, cyclohexane is what? Equivalent to hexine. And hexine is what? It has 2, and hexine here is what? 2 bond. So but in cyclohexane you find out that you have just 2 pi bond. That is 2 double bond. You have double bond 2. The double bond is 2, and that is this is 2 double bond. Not ine. Ine is triple bond, but the bond you find is what? 2. And it has 1 ring. It only has 1 ring there present. And cyclohexane also has one ring. Okay, so just the last examples before we wrap up for the day here is determine the number of fiber on the ring present in number 1, 2 methyl but 1, 3 diene. In this case here, the original form simple is just what? Butane. You should know it's just butane. Butane, that is original. And butane itself, butane is C4H C4H10. That is 4 times 2, 8, 8 plus 2, 10. Now here you just draw this out and you check the compound and you just minus it. So let's quickly reproduce. Butane is for 1, 2, 3, 4. This is for butane, diene. So it's 1, 3. 1, 1, 2, 3. If I'm going to count from here, I'm going to have 1, 2, 3. That's 1, 2, 3. So this is 1, 3 diene and but. So I'm going to have 2 methyl. Methyl is number 2. 1, 2. So methyl is a 1, 2, 3. methyl is CH3. You know, when you add methyl to it, will change it, like the number of hydrogen will tend to, it will tend to what, depreciate and reduce this. As so what do you have? You have 1 2 3 4. You have hydrogen, hydrogen, 1 2 3 4. No need again for hydrogen. The hydrogen present here is 3 already. That is 1 2 3 4 here. And that means that the hydrogen is surrounding this is 3. 1 2 3. Yeah, 1 2 3 4. You need one hydrogen. 1 2 3 4. Or you can simply say 3 4 hydrogen, hydrogen. So this is what you have as 2 methyl but 1, 3 times. So you want to name it as well, it's 1 2. So this branch here, 1 2 3. So that is 2 methyl 1, 3 diene. And hydrogen present here is what? 1 2 3 4 5. That is 1 2 3 4 5 6 7 8. So you have number of hydrogen present here as HY equals to what? 8. 1 2 3 4 5 6. 1 2 3 4 5 6 7 8 8. So and you know your double bond equivalent is equals to HX minus HY over 2. So that will be equal to 10 minus 8 divided by 2. That will be equals to 2 divided by 2. And that will be equals to what? And this is also similar to A. You get what I'm saying? This is similar to in, okay? Because you have 2 methyl. Because of these branches here, this leads to, this is a proof that for saturated and unsaturated compound, if you get saturated compounds, when there is more branch decrease boiling points in compounds, organic compounds. So branch decrease boiling points. So because of this branch, it's decreased a bit. Example now, butane boils at 35 degrees Celsius. But if I add methyl to this butane now, and I have it as 2-methyl butane, it reduces the boiling point to 28 degrees Celsius. So it reduces it. This will boil faster because of this branch here. Okay, the branch is 2-methyl. So also same way as this, you see this is 1 bond present. This is what in, and this is what you find out, this is 2-methyl butane. So which one will boil faster in butane and this? Butane will boil faster than this. The greater the branch, the lower the boiling point. That is part of physical properties of saturated and unsaturated compound. Okay, so we'll be stopping here for now. And also finally, I want to talk about oxalic acid, and dimethyl ether. So for example, dimethyl ether, remember your ether is also your alkoxy. Okay, so you don't forget that. And dimethyl ether is just like oxy. You can have it as COC this like this. So this is just ether. Okay, you have it, you can say methoxy, metaloxy, or metaloxy, methyl. And also oxalic acid. Oxalic acid is also just like oxalic, is also when you have, I see oxalic from the word carboxylic, so you can have it as C2H2O4, and it's just combination of 2 oic in a group. So you have 2 oic, OOH, and you have it as COOH. So this is just it. So if you now bring this together, you can have it as well. The functional will now be like, if you remember, you have your O, you have your single O, you have your H. So if I want to draw this as well, I'm gonna have attached to it as well. I'm gonna branch this, and I'm gonna say I have C 1 O 1 2 3. I'm gonna have what? OH. So, or you can simply draw it in a simpler form like this. Just be C O. I'm gonna have this as OH, and I'm gonna have the second branch as O, and I'm gonna have this as OH. So that is oxalic acid, and that is that about that. So for you can practice these questions, and just give it an answer. Very simple. Okay, you just practice these questions as well. You see this. Just test you drop the answers in the channel, okay? And this is just drop this answer there, drop this as well, okay? That's number 1. Number 2, number 3, you can just drop let's say CH3 or C2H5. Okay, so calculate the double bond equivalent, and also name them, name this and write this out, draw this in the structure. So also we exalt God's name shall operate. We thank you, Lord, for how much more you have been so good to us. We exalt your name, O Lord, Selah. We give you all the praise, Yeshua. Say be glorified in the name of Jesus. We say the end period of this class now. God, we say grant us greater grace and understanding in the name of Jesus. Amen. So also don't forget to subscribe, like the channel and subscribe. And also, yeah, I want to drop my contact here. You can also reach me on the contact here. I will drop the contact on the channel. Okay, my name is once again Prof. You can call me Prof here. Okay, nickname, or you see peculiar channel in the peculiar channel. Okay, this is the channel name, and my name is Prof. All right. Enjoy the day. Have a wonderful day. Okay.